Hi everyone, welcome back to Art of the Part. In this video we're going to continue on with our business card holder case study, and in the last video we looked at the first operation and how to model it in MasterCam as well as how to import it in SOLIDWORKS and process the logos. So this video I'm going to spend a little bit more time on second operation and talk about some 5-axis approaches and how to index or swivel the table and lock it into place so we can take face mills as opposed to trying to ball mill something out, because it takes quite a bit of time. So that said, I've already created this assembly for you. If you are in class, you can go ahead and download that from the Google Drive. However, if you're just creating this on your own, there's more than enough content on my channel talking about how to assemble the 5-axis vise and riser, and then I just put the business card holder here on two 1-inch parallels. Okay, so first and foremost, let's go ahead and get our machine set up as well as our tool library imported. So I'm going to go over here to machine. And then my mill, I'm going to just choose the default machine. And then likewise, I'll go over here, again, good practice, to come into the tool manager. And inside tool manager, we don't have anything in our library or our magazine. So I'm going to search for my DMU50 library here, and then I'm going to highlight all of these. And then I want to copy it up here into my magazine. So I'm going to go ahead and use the arrow to copy it up here so I can pull from it when I'm making toolpath. All right, so next thing I want to talk about are the planes of this assembly. So if you right click in the free space here and I go to top, this is of course is coming from SolidWorks. So the orientation of the planes are going to be a little bit screwed up. However, I think that works to our advantage because it's putting us in a good habit of setting up our planes, which are absolutely needed when we're indexing and rotating the tables for 5-axis. So let's go to planes here down in the bottom tab on the left hand side, and we're going to have to reorientate this so we're looking down onto second operation. So like we've done before, go ahead and click on the plus button in planes, and then we're going to click on dynamic. So once we click on dynamic, we should get our gnomon here, and we're probably going to have to fish for it a little bit, but there should be an origin that is coming from SolidWorks somewhere in the middle of our part here. And you can see how mine is locking here, and I'm just going to go ahead and click. And we have to rotate around X, or in this instance the A axis, so that Z is pointing up. So I'm going to click on one of these red segments, and I'm going to lock my Z at -90. I'm pretty happy where that is because that's going to be at my top face for my origin of the part. And I'm going to name this second op top, and then hit the green check mark. Okay, so now that I've set up this plane for this orientation, I want us to kind of keep in mind some of the things we've talked about in previous videos, and so that we have to set up our WCS, our C, and our T. So when we set up our WCS, our C, and our T, that's just realigning our origin so that when I right click on top, I'm always looking down on the part, as well as my toolpath and my geometry are going to be created from this angle. However, when we create additional planes for each one of these swivel rotations, you must always, and double check this, that your WCS is from the second op top. So our second op top is almost working like, or the WCS in the second op top is almost working like a G54 offset, or whatever offset command that you have. So you don't want to be calling up multiple offsets inside the same program because the machine is going to start to lose track of where it's at. So even though that we're going to create multiple planes here for each one of these swivels, just make sure that we have a WCS set here. Okay, so now that we got the first plane set up, I'm going to start bringing in some additional configurations and setting up planes accordingly to those as well. So let's hop over here to the levels tab, and you'll notice that we have our business card holder as well as all these different components that came in with the assembly vise and the parallels and things like that. So I can easily toggle them on or off. That's fine. I'm going to keep them on here, but I just want to show you if you're having trouble kind of zooming around, you have total flexibility in turning these pieces off. So what we're going to do is we're going to try to match up some of the configurations that we made to the levels that we're making. So if you remember, we made a first cycle 800, which is our first swivel rotation, and so on and so forth, all the way up to 5. So I'm going to make 5 different levels here that I'm going to paste or merge those different configurations onto. So go ahead and add a layer here. You might want to add a couple, so we can go 5 here. And I'm just going to name these accordingly. So I'm going to name them first cycle. And if you're dealing with swivels and that's how you think of it, you can title it like swivel rotation. But I'm going to do first cycle 800, second cycle 800, third cycle 800, fourth cycle 800, and then we'll get the fifth cycle 800. Now this is important because whenever we're pulling in a new part or we're merging something into MasterCam, it's going to try to drop that part onto a level. And we don't want these levels to have multiple entities, especially if we want to be able to like turn things off quickly, because you're going to be locking everything into one level. Obviously, you can kind of move them around if you like right click on it, and then you can change the level here. However, I don't want to have to do that for every single part. So I'm going to go ahead and I'm going to click on the first cycle 800 and make sure that my check mark is next to that first cycle 800. And I'm going to merge in some of my SolidWorks SolidWorks configurations. So if we go to File, Merge, and we come in here to merge, we have to change this from all MasterCam files to all files. We're going to look for our business card holder, and then I'm going to go ahead and hit Open. So when I click on that, you'll notice that it's asking select the desired SolidWorks configuration to be imported. So we're going to go ahead and select that first cycle 800, hit the green check mark, and then we're going to choose the active level. And it might bring up the configurations again, we'll probably have to choose it. So make sure that we have active level selected because that's the level that we're currently on. And we're going to select the first cycle 800 right there, green check mark. And then we can hit the green check mark because we don't have to position this. I set up this assembly so that whenever you drop a part from the SolidWorks file, it's going to drop right onto the center of the vise. So we'll hit the green check mark. And you'll notice that I now have that configuration that we set up for the first cycle 800. So I don't have to try to mess around and try to align the geometry in such a way where maybe I'm trying to remove geometry or create some wireframe to just access this one portion of the cycle 800 or the swivel rotation. So I can turn off my business card holder finished model underneath it, or I can turn that back on and turn off my first cycle 800. I just got to switch my levels here. So however you want to process that. So I'm going to go ahead and populate the rest of these pretty quickly, and I'll be able to turn them on and off as I need. So second cycle 800, we're going to put the green check mark next to the cycle 800 here, and then once again, File, Merge, and then we're going to look for our business card holder in the SolidWorks file, and we're going to go ahead and hit Open. And it's defaulting to active level now, so I don't have to go through that back and forth anymore. We'll hit second cycle 800, green check mark. All right, green check mark. We'll hop down here to third cycle 800, File, Merge, find our file, Open. We're going to choose the third cycle 800, green check mark, green check mark. Once again, green check mark next to the fourth cycle 800, and then we'll go ahead and File, Merge, find the file, Open. Fourth cycle 800, green check mark. And then lastly, we're going to get this fifth cycle 800. And we'll go to File, Merge, find our business card holder file, Open. And then we'll get this fifth cycle 800 right there. And we'll hit the green check mark. So now what I've done is I've isolated all of my swivels, which might make it easier for me to process this. So I can kind of toggle through these. For example, if I just click on the first cycle 800, I can turn these off. And then if I'm done getting this profile here, I can hop over here to the second cycle 800, turn that one off. Hop over to the third cycle 800, turn that one off. Fourth, turn the third off. fifth, turn the fourth off. And you can see that we're kind of trying to remove some of the geometry, so it just makes it a little bit easier to pick from. I also wanted to show you one way that you could process this into MasterCam. However, you lose a lot of your editability there. So for example, I'm going to turn all these off and turn on my business card holder, put my check mark next to that. And I'm going to create a new level here, and I'm just going to call this copy remove. So what I'm going to do is I'm actually going to remove some of these features using MasterCam, which might save you some time. However, I prefer to set these up as configurations because I can link them to drawings in SOLIDWORKS. However, I can't do that with MasterCam. All right, so if I go into this copy remove, I'm going to right click on our business card holder, which is the first level, and then I'm going to copy the entities. And you can see here there are 0 entities in this copy remove. If I click on this copy remove and I right click on it and I paste the entities, it's going to populate with that one entity, which is going to be this exact copy here. So I can turn off my first level, which is going to be our business card holder from SOLIDWORKS. And then once I turn that off, nothing really changed because we just made a copy of it. However, I want to make sure, and this is very important, that we have our check mark next to the copy remove and that there's the one entity populated there. So what I can do is I can hop over here to model prep. So inside of model prep, I have the ability to remove certain features in MasterCam. So this kind of works like a suppress, but there's no going back. So if you think about it, you're kind of just locked into this decision here. I can't even undo it. So if I go and click on modify feature, so it's this little modify feature, it's like a little step with a pencil next to it. Click on modify feature, make sure that it says remove. And then when you click on that remove, you can select, and I'll hold down the shift key and I'll double click, which is going to try to select all of this pocket or all of that feature. So if I double click on that, it's going to highlight all this detail here and recognize it as one cut extrude. And when I hit the green check mark, it's actually going to remove that feature entirely. So if I click on that green check mark, you see how it removed it? So all that geometry is now gone. I actually can't go back here into solids and try to find that and remove it. So keep that in mind and take that with a grain of salt in how you can process this. But I'll just show you how to process the rest of this and how to get rid of some of this. So I'll go to modify feature. Once again, hold down the shift key, double click on this pocket here, and then make sure it says remove, hit the green check mark. Do the same thing with these holes. You don't necessarily have to do this. I'm just showing you it as good practice and how to process this if you weren't dealing inside of SOLIDWORKS and using the configurations. And you can actually take this to pretty extreme levels here. This one I don't believe I can go ahead and like double click all the details, so I have to click it one by one. Green check mark. And it's pretty powerful. I mean, getting rid of that geometry and actually merging and bridging these two details is pretty impressive. So once again, just kind of keep that in the back of your mind, especially if you're trying to process more complex parts. So that said, I'm just going to go ahead and hop back over here to the first layer, which is going to be my business card holder, and I'm actually going to turn off this copy remove. I just was showing you that as an example. Okay, so now we're going to have to set up additional levels. So if we go over here, or additional planes. So if we go over here to the planes tab, we have to set up a new plane, or it's going to be a new swivel rotation with a cycle 800 for each one of these faces. So what I'm trying to do is I'm trying to walk the machine, I'm trying to teach the machine to walk over to this edge, and then at that edge you're going to rotate it at a certain angle. So each one of those movements we're going to have to try to keep in mind. So we're going to make a couple new planes here, and this is where hopping back and forth to our levels and accessing some of these different swivel rotations and the configurations is going to help us out. So I'm trying to grab a corner here. I'm not totally convinced that this corner is exactly what I need for this first cycle 800, which is going to rotate the machine like this. So what I'm going to do is I'm going to hop over here back to levels, and I'm going to turn on my first cycle 800 and turn off my, I'll probably have to put the check mark next to the first cycle 800 and turn off my business card holder revised. So I'm trying to walk the machine from this origin point over here to this edge, and then at that edge I'm going to then rotate the machine. So I'm going to hop over here back to planes, and inside of planes I'm going to once again use my create new plane, dynamic, and then this is pretty easy. I just have to line myself up, maybe here on the midplane here, which is fine, or the midpoint here of this line, and then once I click on it, it's highlighted yellow, and it's facing up in Z. Click on that. All I have to do now is I just have to rotate this around so it's in line with this face. So I know that this is 30 degrees, so I can click on the one of these green segments, which is now going to be the B axis. So I'm going to click on one of these, and then inside the compass, we're going to go to 30 degrees. So you can see that's lined up pretty good there. And I'm going to name this first cycle 800. And you can see that it moved over an X negative 1.0937. So that's what I'm saying when you're like walking the machine over from its original G54, the center of the origin, and then from that position, you're basically telling the machine walk over to that negative 1.0937 in X, and then rotate the machine or rotate the table at 30 degrees in the B axis. So we'll hit the green check mark, and if I was going to program on the face, I would then have to change it to the C and the T. However, I'm going to go ahead and try to process this so that I have all the planes that I need before I go ahead and start making toolpath, because I think it'll be a little bit easier for us to kind of pull from this library of planes rather than having to make some geometry, come back, make some geometry, come back. So kind of going to repeat myself a little bit here in terms of jumping back to the levels, jumping back to the planes, levels, planes, levels, planes. So we're going to go back here to levels. We're going to turn on our second cycle 800. We're going to put the check mark next to that second cycle 800 and turn off the first cycle 800. So now I can see this side here. Okay, so then we're going to go to planes once again, and we'll create a new plane, and we'll create dynamic. And once again, I'll just kind of try to grab the midpoint here, grab that point, and then I'm now going to rotate in the B axis again using these green segments, and then rotate it to 30 degrees. Okay? And then I'm going to name this second cycle 800, and then hit the green check mark. Okay? Once again, we'll hop here back to levels. I'm going to turn on my third cycle 800, put the green check mark next to it, turn off my second cycle 800. And this one is actually going to be on that face. So we're trying to remove this whole material here. And this is at 5 degrees. So I'm going to go to planes. I'm going to get my dynamic once again. And then I'm going to hover over this edge here. If it wants to give me the point here. If I'm not getting this midpoint, they're kind of grabbing it. There it is. You could always grab one of the corner edges as well. But this one is going to be around the A axis, which is going to be X. So I'm going to take this and I'm going to go to 5. And then we're going to name this the third cycle 800, and then hit the green check mark. Okay, hop back here to levels. Fourth, turn that on, put the check mark next to it, turn off the third, and that's going to be this front face here. So we'll go back to planes. We'll grab the dynamic. This is almost like a compound angle because what we're doing is we're rotating it from the 5 degree point. And then if we were doing this at the machine, you'd probably have to do some trigonometry to find out where this exact edge is. However, here in MasterCam, I can go ahead and just like click on it and rotate it that way. So I'll click on that edge there, and then I'll rotate this an additional. So this is compound from 5 degrees. I don't have to account for it in MasterCam, but this is going to be that 25 degrees up here at the front. So I'll go here to 25. And just make sure that's in line. It's pretty good. And then we'll title this fourth cycle 800. And then lastly, we'll come out to the fifth, which is going to be this front side for the nameplate. And I'll jump back here to levels, turn on my fifth, green check mark, X. And I can go ahead to planes, hit the plus button, dynamic, and we can just grab that face. And this is going to be either 75 degrees or 15 degrees, however way that you're looking at it. So once again, we're kind of rotating around the A axis here. So I'm going to grab one of these, and then I'm going to go to negative 15, like that. We could, if we wanted to, and I'll probably talk about this more in an optimized programming video, but if I wanted to, I could make a swarf. And that said, I think I even set this up at the swarf. I actually have to adjust this so that the Z is pointing up because I want the machine to rotate like this so that I can actually engrave. So I want Z to be facing up. So quick fix there. Go ahead and grab one of these red segments, and then we're going to go to, we'll have to add that 90 degrees back into it. So we're just rotating it back so that the Z is facing up. And I'll name this 5th cycle 800. So the first way that I did it was kind of muscle memory. If I wanted to make it a swarf pattern where I'm cutting with the outside edge of the tool. However, I'm cutting with the base of the tool here because I want to use the same plane when I'm engraving. So I'm just trying to make it simple here for the lesson that we're doing. So I'll hit the green check mark. And now I should have all of my planes here, ranging from the second op top, which is going to be our work offset, all the way down to the 1st, 2nd, 3rd, 4th, and 5th cycle 800s. Okay, and you can see that you could just as easily pick up all those edges here using that copy remove that we made. Definitely gives us all those edges that we need, except maybe these 1st and the 2nd swivel 800, swivel rotation cycle 800. But again, kind of however way that you want to approach this. So now that we've set up all of our planes, let's go ahead and start applying some toolpath. So I'm going to go back and just turn on my business card holder. Actually, I want to go to the 1st cycle 800 and turn this business card holder off, put the green check mark next to the 1st cycle 800, and then we'll also grab the copy remove here and turn that off. It's just going to save me a couple clicks here in the next few steps. So first and foremost, I'm going to create some wireframe geometry as well. So I'm going to create a new layer for the wireframe geometry. I'll go wireframe. And just like that, I'll go ahead and create a stock model for this as well. So inside that wireframe geometry, you can go ahead and hop over to the wireframe, and we'll go click on bounding box, and we'll just make this from the center, and then we'll give a value here of 3 inches, or sorry, 3.75 by 3 by 1 inch, so that we're extruding in both directions here with the green check mark. And then we'll go over to our toolpaths group, or sorry, the properties, and then we'll get our stock setup, double click on that, and we'll do the exact same thing with the bounding box. And we'll grab the manual, clicker, and selection, and then from the center there, we'll make it 3.75 by 1 by 3. Okay, and then we'll hit the green check mark, and we'll hit the green check mark once again. And if we're having trouble finding where that stock geometry or that stock model is, we can always hop over here to the toolpaths tab, and then we can toggle the stock display so that we see it. So it's matching up to all the lines that we set up already. Okay, so we're going to do a face mill here, and then we'll hop over and do the 1st cycle 800. So go over here to planes. Just make sure that you're on the 2nd up top. We have our WCS set to the 2nd up top, as well as our CNTs, because that's our first detail here. So inside toolpaths, we're going to go to face mill. And again, we don't really necessarily have to set up the wireframe geometry. I just get in a good habit of doing it, but it allows me to go ahead and just like click the chain that I'm looking for. I could fast forward through it with the red button there, green check mark. Tools, I'm going to go ahead and find my 3-inch face mill, and we'll just title this 3-inch face mill. Okay. Cut parameters, we're going to change this from 1 way to 1 pass. Approach distance will be 25%, 25% exit. We're going to leave nothing on the face, and then we'll go to depth cuts. So again, we can always go back and reference our tool library, and we can go to our 3-inch face mill. And I can see that my depth pass max is 60 thousandths there. So I'm just going to type in 0.0625. I believe we're only taking off 30,000, so this really isn't going to come into play. However, just good habit to always keep the tool down. Linking parameters, I just try to default these all out to absolute, 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 absolute. Top of stock, again, it's about 30 thousandths above the part, so if I wanted to, I could click on the wireframe geometry there, and then depth, we can just grab one of these corners on the top face to make sure that that's 0. And this is where we're probably going to have to start checking another parameter here, and that's going to be the planes, and just make sure that we're always registering the planes that we want. So whenever we're going into an additional and future toolpaths, we want it to read second up top for our working coordinate system, which is our WCS, and then our T and our C, which is our tool plane and our comp construction plane. We're probably going to change those given the swivel rotation. So this first column should always read second up top, and then we'll hit the green check mark. So I have the geometry that I want. Why don't we just go ahead and verify it just to double check that everything applied. So I can go over here to verify. Okay. So, all right. This is a good point to talk about how to turn on our vise and riser assembly as well. So right now I just see my stock model for the part. If I wanted to see my full assembly here, I can click on the workpiece inside of the Home tab of Verify, and you'll see that my workpiece is hidden there underneath it. And I can actually toggle it so you can actually see through it, so it's transparent, and then I can turn it off completely. Likewise, I can turn off my wireframe if I'm tired of seeing that, and I can see what this would look like with everything on with the assembly. So I'm going to slow this down. Be a little faster. Take one pass off the top. And one thing I want us to kind of keep in mind here too is we really haven't looked at this too much lately, but I want you to look at the feed time. So that one operation was only going to be about 5 seconds. So as we try to start to optimize our program, these numbers are going to start to increase, and we're trying to keep that down because I think once we apply all the geometry, it's going to be around like 26, 27 minutes, and I'd like to see this part cut in under 15 minutes. So I'll make another video about optimizing the toolpath. However, we're just going to try to get all the toolpath in place with this video. Okay, so we've taken our first pass off the top. Now let's go ahead and process or try to cut this first cycle 800. So if I go over here to the planes tab, again, you want to keep this second up top, which is our work offset, as the WCS, or the working coordinate system. We're just going to change with this first cycle 800, this first swivel rotation, we're going to change the C and T plane for that first cycle 800. So you can see, I'll just go back here, you can see that the Z plane is now facing up as if the table is rotated in the B axis there. So we're going to go ahead and hop over here to the toolpaths, and now we're going to do the face mill once again, but we're going to utilize the geometry of this entire face. So if we had the part open where it was like this, I'm going to turn off my first plane. I might be missing some geometry here, especially if I'm trying to rough this out. So that's why it's helpful to kind of create some of these configurations, because I don't want my toolpath to be stopping short. Okay, so I'm going to go back to the first cycle 800, put the check mark next to it, and then turn off my first level, which is the completed business card holder. Okay, toolpaths, and then we're going to grab that in the 2D gallery here. We'll grab the face mill. And I'll have to change from wireframe. I'm actually going to go here to solids. And inside solids, I could grab this whole face. However, I'm going to advise you against that because it's going to include this hole here. So again, if you try to remove that detail with the configuration, it might be helpful. However, I'm going to try to process this where we're going to do all of our swivels and then do all the milling on that swivel. And then I'll show again in another video if we wanted to try to optimize it with swivels versus tool changes. So I did want to include this with this specific configuration in the way that I'm processing it now. However, we don't want to click on this face because it's going to try to mill around that circle. So what I'm going to need to do is going to change this from face to loop, and we're just going to grab this loop here. So don't grab the face, grab the loop, which is the outer extent of the detail. Hit the green check mark, and we'll go over here to toolpaths. We probably won't be able to utilize the 3-inch face mill, and I can show you because it's a little bit too big, and I'll just do a really quick toolpath here. Don't exit out of this page. I'm going to show you what it looks like in my verify. We'll do the one pass there again, and link your parameters. We'll go to top of stock. It's reading a little bit differently, which is fine. And we're going to go to planes and make sure that it's reading second up top, first cycle 800, first cycle 800. So even though I hit the green check mark, you're going to see that it's probably a little bit too much for this specific operation, especially if I'm going into my verify. I think the tool is just a little bit too big when you're considering that there are other details underneath it. And we're most likely going to be hitting into our vise. Even if we're coming the opposite way, coming this way, we're probably going to hit the vise too. And I'll explain how some of that works here. So I'm going to go back into that facing, and if you were at this point, if you didn't follow me, that's good. So we're going to hop back here to the 5/8 end mill rough, or sorry, end mill finish, and we're going to name this 0.625 end mill, and we're going to name put a note here for first cycle 800, and we could put like face after it as well. So I just wanted to show you why we're choosing this 5/8 end mill over the 3-inch face mill, because previously in every video we've always used the 3-inch face mill whenever we're facing. However, you can utilize other tools using that face mill option. So we'll hop here to cut parameters. It should still pick up some of our details from the last toolpath that we generated. So it's going to go to one pass. However, we're going to change this to zigzag because we have a smaller tool. We can't actually do this face all in one pass. And we're going to come back here and adjust the overlap as well as the angle that we're approaching. But I wanted to generate the toolpath first and then show you what that looks like. So depth cuts, we actually will have to update this a little bit. I would probably say that with the 5/8, we could go to 312 depth to cut. However, I want my tool to be a little bit sharper. We could optimize it and use like the rougher tool and go the full depth, but I just don't want to make a bunch of tool changes here, especially when we're doing cycle 800s and swivel rotations. So I'm just going to utilize this tool but go half that depth. So I'm going to change this from 0.0625. I'm just going to make it 0.15625. And then make sure that the keep tool down is selected. Linking parameters. This is going to be a little bit different. So right now the top of stock is kind of reading where the stock material is from what we set up in relation to where that plane was set up off that face. So if you think about it, there is still material here from this face to that corner, and that's where that measurement is coming from. So it's measuring this flat face because we set up our zero plane for the swivel at this edge, and we've now rotated it so we still have material from basically this corner up here to that corner. So that's what it's registering. We could change that if we want to. However, we want to account for that material, especially when we're trying to rough it away. So go down here to planes, and inside that planes, make sure that you're reading second up top for the working coordinate system, and then first cycle 800 and second cycle 800. And then we'll hit the green check mark. Okay, so that's looking a little bit better. We're not going as far down. However, I'm worried about especially like this edge here. And when I project the tool, I'm actually going to backplot this as opposed to verify. And I'm just going to fast forward here to the end. And you can see really quickly that we're going to hit the vise. We're going to hit our hard jaws. So not exactly the toolpath that I'm looking for. However, I can make some slight changes to improve this and try to optimize it a little bit better. So I'm going to hit the green check mark on my backplot, and I'm going to hop back here into my parameters. So inside parameters, we're going to go here to my cut parameters, and now I can actually manipulate my geometry a little bit more. So we've never really explored this. However, I am going to change the angle of approach because right now I'm cutting this way, so I'm like zigzagging this way, but I want the zigzags to go this way, so up and down the part. So if I change this, I could either try to auto angle it. However, I like a little bit more control here, and I can go ahead and just type in 90 degrees. So I'm actually rotating my toolpath. And then my across overlap, I'm going to change this anywhere from like 10 to 15 percent. So I'll make it 10%, try to tighten it up, and then hit the green check mark. And you can see with two changes there, it got rid of quite a bit of toolpath. And not only that, it optimized it in such a way that I'm actually going up and down the part. And when I backplot this, I'll just pull this all the way down here to the end. My tool is, oops, go back a little bit. My tool is well and away from the top edge of the vise. So very important that we investigate that because we don't want to accidentally crash into our vise and have to repair our spindle or break a tool or something like that. Okay, so pat yourself on the back. That was the first swivel cycle 800 that we did with 5-axis. So that's called indexing. We're just locking the table in and we're taking like a face mill. So if we were trying to do this with traditional methods with like 3-axis programming, we'd have to either create a custom vise or work holding assembly so that we rotate the part in 30 degrees and then cut it like we just did, or we'd have to try to ball mill this out, which would take quite a bit of time. And I'll pull up another file, especially when we're talking about like the optimized tool paths, and I'll show you like the difference in terms of time and everything like that. Okay, so we've done one of these, and now we're going to hop over and we're going to do the second cycle 800. Oh, my apologies. We actually have a hole to drill here. So before we hop over here to that second cycle 800, let's go ahead and plunge that hole. Pretty simple. We're still in the same working coordinate system in the C and the T planes. So we'll go over here to the 2D gallery, drop this down, and we'll grab the drill. So we'll get that drill, and we're just going to grab this hole, and then it's a 1/2 inch diameter, so I know that I have to pull a 1/2 inch tool. So I'll hit the green check mark tool. We'll go and zoom down here, scroll down to the 17th tool, which is going to be our 1/2 inch drill. And I'll just give a 0.500 drill, and then I'll title it first cycle 800. Okay. Cut parameters. We can just leave it as a standard drill here. You don't have to pack it or anything. Hop here to the linking parameters, and we'll just do absolute, absolute, and absolute. This is one detail that we are going to change here because the depth is reading at that top base. We'll hit the depth, and then we'll actually grab that shoulder there. So we're going that distance down. Okay, tip comp will be important to include. Even though that we're not breaking through, I want to tell the machine or the program or the G code that we do have a 130-degree tip angle here. So I'm going to turn that on. My breakthrough amount, I'm going to put 0, but my tip angle is going to be 130 degrees. And then again, good habits get into, but look at their planes. We got second up top, first cycle 100, first cycle 100. Green check mark. So we got our drill there. We could do like a transform and mirror this over, but I'm just going to do our reps here and try to do everything by hand so we have some control over it. Okay, so let's go ahead and hop over here to our planes. We're going to now go to our second cycle 800, C and T, so you can see where it rotated. I'm also going to go over here to my levels because I want to be able to pull that hole. And I'm going to turn on my second cycle 800, put the check mark next to it, and turn off my first cycle 800. Okay, and again, I'm just trying to get our reps in, so let's go ahead and do this once again. So we'll go hit the drop-down menu, we'll get face, and then we'll, instead of getting the entire face of this, make sure that we're choosing the loop. So we'll get this loop right here, green check mark, tool, we'll get the 5/8 end mill, and we'll title it 0.5625 end mill, and I think we named the last one like first cycle 800, but this time we're going to name it second cycle 800, and then we put face after it. Okay, And then we'll do cut parameters, zigzag, it's remembering everything that we had before. Depth cuts, still the same. Linking parameters, pretty much the same. Again, good habit, but make sure we're here in planes. If you missed that portion where we went to the planes and we changed it to the second cycle 800, you do have the option here to look up from your tool planes here. So there's the second op top, which should be that working coordinate system. However, if you're seeing first cycle 800 in both of these columns here, you can always click on this select tool plane, which is this little box, and then here you can choose what planes that you want to be pulling from. So we want to make sure that we have the second cycle 800 selected. And I'll just show you a bad example, but if I had like the third cycle, I could put that there. And if I wanted to copy this to that next plane there, I could go ahead and hit this little fast forward button, and then it would go to that. However, I want this to read in the second cycle 800, and I'm just going to copy that back over there. Okay, and whatever plane that you have is going to be relative to where the linking parameter is pulling the top of the stock from. So once again, imagine that we're at the zero phase here, and then we've included or that we created stock in that direction there. So this whole little sliver here. And I'll hit the green check mark. Okay. So you can see that we have a very similar toolpath mirrored over on the other side, but we created it. It's not like a transformer mirror. And then we're going to go and hit the drill command, and we'll do the same thing there. So drill command, and we'll grab this hole, 1/2 inch diameter, green check mark, tool. We'll just grab the 1/2 inch drill, and we'll title this 0.5 drill. And we'll do second cycle 800. Okay. All this should be relatively the same. I'll just double check my parameters here. Absolutes, tip comp, 130, planes, second and second. Okay, so green check mark, placed my drilled hole. Okay, so that's now our second rotation, or our second cycle 800. So we're really cooking with gas here when we're talking about indexing and 5-axis programming. So we'll go over here to levels. Once again, we'll turn on our third cycle 800 because now we're going to move into this phase. And then we're going to turn off, or put the check mark next to the third cycle 800, turn off the second cycle 800. Planes, we're going to change our C and our T, only the C and T for the third cycle 800. And we're going to do a face mill with this, this detail here. So go to face, and if you wanted to, you could hop over here to the toolpath so that you see that it's generating. We'll just grab the loop again rather than this whole face. We could grab the whole face, that's fine, but I'm just going to grab the loop here. And you can see how this might not be advantageous if we had that like chunk taken out in the front there. So if we were just grabbing the finished model, especially with that fourth cycle 800 included, it would probably end right here. However, we don't want to leave that material, because when we eventually come to that fourth cycle 800, we want this material to be removed, because we don't want to like accidentally try to plunge our tool when we're rapiding and too close to it. So I'll just grab this whole face. I'll hit the green check mark, go to toolpaths. This time we should be able to utilize the 3-inch face mill, and we can do like a single pass across. It might make it a little bit quicker. So why don't we go ahead and get that 3-inch face mill there. We'll do this once again. And there's some thought process behind optimizing your toolpath and using the tool that you currently have out, as opposed to doing a tool change. And we'll talk about that in another video. However, I'm just going to do this in like the simplest terms. So we'll do a 3-inch face mill, and then we'll put after it, this is going to be our third cycle 800. So kind of imagine this video as that we're not really caring about the final run time. We're just trying to get all the toolpath in right away. So zigzag, we can change this back over here to 1 pass. I'll actually show a bad example, but if we forget to change this 90 degrees, it's actually going to plunge the wrong way. So I'm going to leave that. We do want it to be 0, but I want to show what it looks like. Okay, depth of cut. We're going to change this back to 60 thousandths. Keep the tool down because we are going to actually be making quite a few passes here. Linking parameter, you can see that we do have some material that's hanging out above here. So absolute, absolute, absolute. We can go here to planes, and we're reading second op top, and then third cycle 800 and third cycle 800. So if I hit the green check mark, tool diameter is not big enough for the one face. So I think that was because of the 90 degrees. I was actually hoping that it would plunge, but let's go ahead and change this back over here to depth cut. And we'll change this over here to 0. So when we did the 0, it's actually giving us the side-to-side motion that we wanted. I wanted to, and maybe I'm a little bit destructive, a little bit of a masochist here, but I wanted to see the tool actually plunge into the face of our vise here. However, I was not able to replicate that this time. Okay, so this is where we're going to have to hop back and forth between our different levels, and especially our configurations. And I'll show you exactly what I was talking about with why we wanted to include this entire face and isolate this swivel from the 4th cycle 800, because I have a pocket that I have to mill out now too. So if I go over here to levels and I turn on my finished business card holder, you'll notice that I do have a pocket that's underneath, which is going to hold the sticky notes. So I'm going to put the check mark next to my business card holder and turn off my 3rd cycle 800. And you can see that the toolpath, if I just did this loop from that edge here, I would be missing some of the material from the slot where it's going to hold the business cards, as well as this detail in the front where it would truncate it a little bit shorter because it's angled to hold that day plate or that calendar. Okay, so you can see why isolating out some of these faces or configurations into their own separate levels and planes are really going to start to help us as we approach cycle 800 and swivel rotations for 5-axis programming. So that said, I'm actually going to start to look at some of these more fine details, like the pockets and the slots, as we go through some of these swivel rotations. So this pocket here, since we're on the 3rd cycle 800, we've already milled this face away. I'm going to start to look at this detail here. And this is going to be a little bit tricky for us because I know that these corner radii are pretty tight. And if I wanted to, I could investigate it and see what size they are by clicking on the Home tab, going to Analyze Entity, and I could actually click on one of these corners or radii. And I can see clearly here that the value of that is 0.075. And that's going to really narrow down or eliminate a lot of the tools that are currently in my library. And it leaves only one real option, which is going to be a 1/8 inch end mill, because that corner radius is going to be 0.0625, which is smaller than this 0.075. So that said, consider like we have a 250 or 1/4 inch end mill or a 312 or a 5/16 inch end mill, and that's just going to be too big to swing in some of these corners. However, I can still use them to kind of rough out some of these details, and I'll show you some time comparisons. And I know I said I wasn't going to go too deep into those time comparisons, but some details like this are just too hard to ignore, and I'll show you the comparison there. So let's go ahead and start programming out this pocket. I'm going to click on Toolpaths just so I can see here. And then inside the Toolpaths tab, I'm going to go to Toolpaths. And in the 2D gallery, I'll open that or expand it. And I'll grab the Dynamic Mill option. And since there's no like islands or details that I really got to avoid, I can honestly just utilize the automatic regions if I wanted to. So I can click on that automatic region, select this face, and hit the green check mark, and then choose to stay inside. If I had other details like islands or pockets here, I could say machining regions and grab them, and avoidance and grab that. But that's not really going to be a consideration for us. So as long as I have the automatic region selected and the stay inside, I can go ahead and continue on and hit the green check mark. Okay, so I'm going to choose a tool here, and I'm going to find, and I'll show you again a bad example of this, but I'm going to find that 1/8 inch end mill, which is going to be a pretty small tool here, and I'll title this 0.125 end mill, and I'll put a note here afterwards as a 3rd cycle 800 pocket. Okay, and I'll come down here to cut parameters. I'm not going to leave anything on the walls or the floor, so I'll zero that out, 0 and 0. Corner parameters, not really, don't have to worry about that. Depth cut, we do have to consider this because our 1/8 inch end mill here has a max depth cut of 0.0625. So I will update this. I'm going to turn on my depth cut, and I'm going to go 0.0625. Come here to linking parameters, and I'm just going to do absolute, 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 and absolute. So one thing to consider here, the top of the stock is actually registering from this face here to the stock material. However, we actually cut away all the material above it with that last third cycle 800 face mill. So I'm going to actually change this or update it from top of stock to what the default value is to this top corner there, and it's going to zero it out. And then my depth, I'm actually going to go a little bit below, which is going to be, oops, change that to absolute depth, and then I'm going to get a value of negative 0.125. And now we're going to talk a little bit about the entry motion. So we really haven't explored this too much when we're dealing with pockets here, but I want to just mention this. It's always going to default out here to helix, which in my opinion is the best approach because it's kind of cutting into the material and it's orbiting around the center of the tool, and it's going down in X, Y, and Z. So I think that's a little bit better than just like plunging down and like potential of damaging the tool or the part, as well as ramping down, which is going to put a lot of cutting pressure and going to give you some chirping when you're approaching in. So I think the best case practice here is the helix, and I'll show you here what it looks like in the verify, but when you're in dynamic, it's actually going to give you the calculated value out by the size of the tool. So if I change the tool, it'll update. You really don't have to consider that. And again, good practice always to come down here to planes and make sure that this is registering how you want it to. We see it as second up top, third cycle 800, third cycle 800, and we can go ahead and hit the green check mark. And this is going to take a little bit to process here because of how much toolpath is being generated. And you can see, yeah, there's quite a bit there. And if I wanted to, I can investigate what the total runtime of that would be. And I'm going to just click on this one detail, and then I'm going to verify that out. So I'm going to see what this ends up being. And you can see that time is actually starting to add up pretty quickly. And I have a value here in the feed time of 16 minutes and 11 seconds. And I'll just quickly show you what that helix looks like. But you see how it's rotating around, but 16 minutes is about what I want like the entire program to run. So I think that this is a little absurd, and we should not dedicate that much cut time to this one detail, especially when you consider that if I X out of this and I grab all these tool paths, so what was it, 16 minutes and like 15 seconds or something like that, and if I grab all these details, so all of these details in combination with each other are 17 minutes and 15 seconds in total. So 16 minutes of that, or like 95%, is just dedicated to that one toolpath. And you can kind of see it down here in the play bar where one solid color is one detail. And like if I could zoom in infinitely, you would see how fast it'll cut through all these face mills. And arguably that's like way more material that was removed in 1 minute as compared to how much material is being removed in 16 minutes. So I think that we just have to approach this a little bit differently and try to utilize a little bit, maybe two tools in this instance, and try to cut down that tool time a little bit. So I'm going to hop back here into my parameters for that seventh operation, which is that 1/8 inch end mill, and I'm going to choose a bigger tool. So I'm going to scroll up here, and I think I'm going to utilize the 5/8 end mill since we've been using that quite a bit. And when we click on these tools, one thing with MasterCam 2023 is you have to reinitialize the speeds and feeds because it's still registering or picking up the values from the previous tool. So if I right click on that tool, I can go ahead and reinitialize the feeds and speeds. It'll update it. And then I got to update my comment here to 0.625 end mill third cycle pocket. And if I want to, I can put another note out here. I could do roughing. And I'm going to come down here to the cut parameters. This is more of like a perfect world scenario. I would approach this a little bit differently if I was like doing this in industry. However, I just want to show you the power of the dynamic mill, and it's going to make it easier for us as we approach some other details. So I'm going to leave the stock to leave on walls as 5,000s, but the stock to leave on floors I'm going to leave as 0 because it's not going to work if we try to blend two tools. If there's actually material left on the floor, because it's going to cut the entire pocket anyways if it has to remove that extra 5,000s. So all we're going to do is we're going to update this stock to leave on walls 5,000, stock to leave on floors 0. Depth cuts, I can actually turn this off now because that tool is quite big. It really doesn't have to be limited by that 60 thousandths there. And then we can come over to linking parameters. That all looks good. And I'll just show you here as well. But in entry motion with the helix, it actually updated that value. So before it was like, what, 56 thousandths, and now it's like 280 thousandths. So again, it's like orbiting around the center of the tool. And then we'll hit the green check mark. So it actually reduced the amount of tool paths in there by quite a bit. And if I go ahead and I verify out that one detail, let's go ahead and see what it looks like. So now that feed time went from what 16 minutes and 15 seconds to 30 seconds. And I would take that any day over spending that much time on that one detail. So pretty quick work of that pocket now. However, we are too big to come and clean up those corners. So we hogged out a lot of material here. However, we still have to kind of clean up this corner a little bit, and then there's this little earmark here that we have to clean up a little bit. So that's why we would probably either copy this toolpath or create another toolpath and use a different tool, which is the smaller 1/8 inch end mill. So again, this is perfect world scenario where blending is no issue, but I'm going to go ahead and create another toolpath here and copy that 5/8 inch end mill. I'm just going to copy it, and then down below, I'm going to click paste. Make sure that, again, if your arrows are like up or down, make sure that your red arrow is here down at the bottom of your operation manager, and then click on paste. So I just pasted that tool back in there. We'll come in here to parameters, and again, good practice, but we'll come up here to the tool tab. We'll click on 1/8 inch end mill. We'll update the note here. We'll make it 0.125 end mill, and then instead of roughing, we're going to title this as finishing. And again, here in 2023, we have to update the speeds and feeds here of that tool. So we're going to right click on the 1/8 inch end mill, and then we're going to reinitialize the feeds and speeds. So that will update these values. And then we'll come here to stock, and inside of stock, we are going to utilize this now because there was material that was removed in a previous operation. So I don't have to now spend all the time and remove all this material here because I already removed it with that bigger tool, the 5/8 inch end mill. So I can choose to select rest end mill, and I can either select from all groups, toolpath groups, or machine group, or one other operation. So I think we did a little bit on this with the bottle opener case study. However, we can just leave this as default all groups. If we had multiple operations here, we would probably just have to do toolpath group only. Or if we had a specific detail that we had to avoid, we can click on the one operation and we can choose it from this list. But I'm just going to leave this as all groups because we're just sticking in one toolpath group here. Okay, so then we'll come down here to cut parameters. Stock to leave on walls, I'm going to update this to 5 thousandths. And again, this is a perfect world scenario where the blending is going to be no issue. And then I'm going to come down here to depth cuts. Even though that this said, 60 thousandths here before, I am not going to consider that because I already removed most of the material and I'm just doing some slight cleanup passes. And I think I can go the full depth of that tool without, going into these depth cut steps. So I'm going to leave that off. It's going to go to the full depth, the 1/8. And then we're going to come here to linking parameters. Everything looks good. Entry motion, that updated. And then we're going to go ahead and hit the green check mark to update. So you'll notice that the difference from when I showed you earlier, where there was all this toolpath here in the center, now I'm only, cutting out some of these corner details. And it's just a few toolpaths. So if I look at these two toolpaths in combination with each other, I'll click on the 7th, hold on the shift key, and click on the 8th, and I'll go to verify. So from 16 minutes and 15 seconds, we went down to 1 minute and 39 seconds. And like I said, I'm going to choose that every day over those two operations over that one operation if it's the difference of 15 minutes, especially when the total run time of this part should be around 15 or 16 minutes. So I'll show you what this looks like now. We can go ahead and play this out. And we can even optimize this a little bit more where the 1/8 inch end mill probably doesn't have to helix down into some of these edges since it's already cut away, but I'm just going to leave it at the default values. You can see that it's just cleaning up those couple little edges. One thing I will mention here, and you can kind of see, and I'll turn off the workpiece here, is that the difference between the blue and the yellow, I'm going to say 9 times out of 10, you're going to see that. So in industry, I would probably spend the time and try to figure out my feeds and speeds a little bit more and just use this 1/8 inch end mill and leave 5 thousandths on the floor from the previous operation and just try to move through this as quick as possible so that the entire surface of this pocket is cut with one tool. That's how I would approach it. However, again, in this educational space, I'm just going to show you the power of the dynamic mill because again, we'll use this same approach with a couple other details. So I'm going to X out of that and I'm going to consider that pocket done. So now I'm starting to get a couple operations here. I can go ahead and start to minimize or collapse some of these if I wanted to. I can use this minus button next to each one of these folders, kind of get some more space here to see what I'm working on below. So I'm going to start to move into that fourth cycle 800, which is going to be this face. And I think I'm going to go to the levels here. I'm going to see the difference between the fourth cycle 800 and the finished model. So I have a fourth cycle 800. I'm going to turn that on. And I'm not really seeing any difference in geometry here, so I probably don't have to utilize this. I can go ahead and use the default finished operation or the finished part here to get the toolpath for my operation. So I'm just going to go ahead and bypass this fourth cycle 800 configuration. It's good to still keep it in the background there, and it shows you what's going to be like cut in that operation. However, I really don't have to toggle between them now. However, I do have to go to the planes, and I have to go to the fourth cycle 800, and I got to change my C and my T plane so it updates to that face. So very important, again, make sure that you update that C and that T plane. And we'll come back here to toolpaths, some more room to work, and I'm going to face mill out this detail, just like how we face milled out the other faces. So go to the 2D gallery face. I'm going to use the loop because, again, if I went to face, you see how it's grabbing that pocket there too. I am not going to do that, so I'm going to get the loop, and I'll just grab this entire area here. And I'll hit the green check mark. Okay, so inside of tools, I'm now going to use the 5/8 inch face mill, or end mill to face this out. So I'll just do 0.562 or 0.625 end mill, and we'll title this fourth cycle 800. And then we can put face afterwards. And again, you can probably imagine that we wouldn't use or try to utilize that 3-inch face mill because it quickly make this into a mess with the vise. It's just too big of a tool to cut that detail. So I'm just going to use that smaller 5/8 inch end mill, just like what we were doing on those side faces. So we'll go to cut parameters. We'll probably have to update this from one pass to zigzag. And we might have to change some of these details here, but I'm going to leave them kind of what we had with these other values and see if it gives me what I want. Depth of cuts, we can update this to 0.15625. Linking parameters. Top of stock is going to be from this edge to the top of the stock material that we created. I can probably update this to 0. However, I want to show this and maybe we'll step it down by hand what the toolpath is going to look like. And this is a good investigation in how we can use Verify to kind of improve some of these toolpaths. So we'll come down here to planes. We got second up top, fourth cycle, and we can go ahead and hit the green check mark. Okay, so I see that toolpath. I'm starting to see a little bit too much toolpath here on my screen, so I'm actually going to turn off some of these. So if I select toolpath group 1, I can use these waves, and I can toggle them off, and I can just grab this 9th one, which is our facing here, and turn that on and see what that looks like. So in my opinion, I think after we cut all of these details, it's probably going to be cutting quite a bit of air. Maybe these first 2 passes are going to be air, and it can kind of take that out as I need. So let's go ahead and see what that looks like here in the Verify. And we can also see what the updated time is with those 2 new toolpaths. Okay, so I'm going to go ahead and play this. Our feed time now is sitting around 3 minutes and 12 seconds. I think that's pretty good. Okay, and then we're going to get to right around here, and I'm going to slow it down. So right now it's just doing that finishing of those corners, and I'm going to pause this really quick, slow it down, and I'm just going to move my slider right around there and see what this looks like when we start to get some of these passes. Okay, so it looked like I'll actually rewind it, and I'll just go to here, and I'll slow it down, and I'll play that out. Okay, so I'm just going to let it run its course. So the first 2 passes look like they're not really cutting anything because we already removed that with that blue face or that 3rd cycle 800. So I could probably come in there and step out, and I know that my values there, my depth of cut was 0.15625. So I could take that value, and I can come here into parameters, and go to depth cuts, or sorry, linking parameters, and this value 0.5, I can actually say like 0.5 minus 0.15625, and that's going to give me that value. So I took out one pass. So I'm going to see what that looks like now, and you can see that that blue that blue toolpath disappeared. So let's go ahead and see what that verify looks like again. I'm going to close out of that. Do my, oops, I'll have to grab all my toolpath once again and verify. And once again, I'll just take this play bar, and I'll just kind of zoom up into this edge here, and then I'll see what this looks like. So now that first pass should not be cutting air, it should actually cut into the part. So looks like it's facing off a little bit. I might even want to go down a little bit more. So I could take off like another, 156 and see what that looks like. So I'll come in here, I'll just do this once again, minus 0.15625, and I've got a value of like 187 above as well. Okay, and we'll just do this one last time and see what it looks like and leave it there. Okay, so it's just finishing up this corner, and now we should see a much more appropriate cut across that face. I think that's a little bit better, especially given the size of this tool. So again, we can kind of optimize our tool paths and make it a little bit better. And we'll talk more about that in another video, but just, some quick optimization that we can see there. All right, so we're going to have to do another pocket here, which is going to be the additional detail on that fourth cycle 800. And I think we're going to approach this in the same way that we did with this third cycle 800 and use the dynamic mill. So really quickly, again, good habit, we're just going to investigate what these corner radii are to determine what tool we're going to use. So if we go over here to home, we can click on Analyze Entity. I can click on this corner, and I see that there's a value there of 135. So that opens up a little bit more options for us to use, and I'm going to actually utilize the 250 or the 1/4 inch end mill because that has a corner radius of 125, which is smaller, and it should allow us to swing here in these corners. And I'm just going to go ahead and hop over here to the toolpath tab. I'm going to grab the dynamic mill. And again, there's no details or islands that I got to really watch out for. It's just a simple pocket. So I can get the automatic region once again. I can grab that face, hit the green check mark, and then I just have to have stay inside. So again, automatic regions, that face, stay inside, and then we should be able to hit the green check mark. So now I'm going to hop over here to the tools, and I'm going to choose the 1/4 inch end mill. So I'll get that 1/4 inch end mill right there. And I'm going to type in a value or a note here of 0.25 end mill, and then I'm going to put a note here, fourth cycle 800, and I'm going to put pocket there. We don't really have to do like a cleanup pass like we were doing before with like a roughing and a finishing. If we wanted to, I could come in and maybe use a little bit bigger of a tool, but I think my only advantage here would maybe be to use the 312 end mill and pretty much clean up to near finish and then just take like one skin cut here on the 250 end mill. And we might talk about that with the optimization video. However, with this one, I'm just going to use one tool here. And I'll go over here to stock, and this is still picking up like the settings from the last detail. So the last time that we used the dynamic mill, you just want to make sure that we turn this off because we really aren't pulling any other operations into consideration here. So make sure that stock is turned off. Cut parameters, we're going to leave 0 on the wall, 0 on the floor. And then we'll come down here to linking parameters. And again, like what we did with this other pocket, we really don't have to consider all this other material up here. So I'm just going to click top of stock, and I'm going to grab one of these corners. So it should be 0. And then depth, absolute. I can always check it, but since I already grabbed that face, it's registering as that negative 0.375. Entry motion, depending on if the toolpath is generated or not, we might have to come back in here and adjust this helix, especially since it's a little bit tighter of a slot. So I'll just see what happens here, and I might come back and update that to 0.065, depending. And then we'll come here to planes. We see second up top, fourth and fourth. That's all good, and I'll hit the green check mark. So I'm seeing that value there. One thing I did forget to update here is the depth of cuts. I think that's just way too deep for that tool that we're using, especially for like hogging out all that material. So really quickly, just come back here into parameters, and then we'll just do depth of cuts, turn that on, and change it from like 0.0625 to 125, and I can always check that here inside of my tool library. I have the 250 end mill here, and I can see that I have a 250 or a 125 depth pass there. So I'll just update that to 125, and it's probably going to generate 3 levels there for me. And again, I can kind of see how long that toolpath is going to run. I think it's probably going to take a little bit more time than you would think, just because we're getting at this whole detail here and we can't really utilize that big tool like we could here. We're kind of limited in what we can use. So I'm going to go ahead and check that here in the verify. And that one detail there is running us about 8 minutes. And I could obviously try to change it out a little bit, but I'm going to save that for the optimized video, and I'm just going to leave that one alone. I'm just going to say, yeah, that 8 minutes is fine as is. And I'll go ahead and move on to some of these other details. And I think one thing that we have to consider as we're swiveling these planes is maybe trying to optimize, what details we're doing. And I was doing it here in the background. Maybe you noticed it or not, but I basically was here at the part. I rotated it here, and then I did that face, and then I went into that fourth cycle 800, which we're at now. So if I wanted to, I think the next logical place or location that we would mill is just returning back to the square second op top and then getting this slot here instead of having to rotate back to like the front side and then getting this detail and engraving it. I think I would rather go ahead and cut that face there. So let's go ahead and minimize these, and we'll just change our levels, and we'll grab this wall here. So let's go ahead to levels. Oh, sorry, go to planes, and we'll just change our CNT plane back to the second op top. And then at that second op top, I'm at that square level now, and I can grab this slot detail. So we'll go into toolpaths, and this should be pretty easy. We could probably utilize the dynamic mill once again. If I want to go to dynamic and then automatic regions, again, I can just grab this face there and then hit the green check mark. And then I can just choose to stay inside. And I'll go ahead and hit the green check mark. And we'll go to tools. This is a little bit wider. If I wanted to, I could kind of measure this out, but I know that value is about 0.406, so I can use the 312 end mill here. And I'll just title this 0.312. And I'll actually end up doing this in one operation as well. I could, and I'll save that for the optimized video, but I'll probably do like a roughing operation, and I'll do like a final like skin pass here to kind of clean up the edge. I'll probably do that in both these details, but for what we're doing in this first video, just trying to get our toolpath established and trying to gauge what our total runtime is, let's just do this in one pass here. So I'll do 0.312 end mill, and then we'll title this just card slot. Okay, and then we'll make sure that the stock is turned off. Cut parameters, stock to leave on walls, we can leave that 0 on 0, and then we'll go down to here to depth cuts. We might have to adjust this a little bit, especially for like running it, but I'm going to look here at the 312 end mill, and it's saying I should be able to go down to about 156 per pass. So I'm going to change this and update this to 0.15625, and I'm going to come here to linking parameters, and it's saying top of stock. It's still registering that top mesh there, so I'm going to update that. Top stock, we really only got to worry about that detail right there. Depth, it is recognizing it as that bottom floor, but I can always double check it. It's still getting that negative 0.75. Entry motion, this really isn't going to come into play. I think the dynamic mill should recognize it and adjust it as it needs. And then we'll go ahead and do planes, second up top, all that's good. And then we'll hit the green check mark. And it did recognize that there wasn't any geometry there in the walls, so I didn't have to actually adjust anything. And it's just going to break through that wall on its own, which I think is pretty smart and powerful technology here in that dynamic mill. And that's why I chose to use that with this specific operation. So I'm going to see what this looks like in Verify. And I'm going to go ahead and select my entire toolpath group 1 so that there's a check mark next to each one of these folders, and then I'll click on Verify. Again, you can see, I mentioned this at the beginning of the video, but our feed time is a little high, but it should be around that 26, 27 minute mark. And there are some obvious culprits like those dynamic mills that we just did. We did spend some time, and I'm going to let this play out here, talking about this detail with this pocket where it was going to be about like 16 minutes. However, I think, again, this is just too big of a culprit to ignore, and that's why I went ahead and did a roughing operation, and then I did like a finishing cleanup pass with that 1/8 inch end mill. And you can imagine if there was like 16 extra minutes in this file here, we'd be easily up there in that 40-minute mark. This 27-minute mark is a little high, but like 40, that's just, that wouldn't cut it. So there's opportunity to go ahead and try to optimize some of these toolpaths. And again, I'll let this play out a little bit. And I'll talk about the dynamic mills that we just did. So this detail here is going to be the exact same approach as this detail here, but what it's doing, and it might be easier to see against these two colors here, but it's essentially taking the end mill and it's kissing the material, and then it's coming back, letting the chip escape, and it's really taking out a lot of that heat that is generated by just plunging and cutting across. So in some instances, I think dynamic mill is just like way too smart for its own good, which is good for us because I don't have to try to manually put these cuts in. So it's going to take a little bit to cut through this detail, but it's really like extending the life of the tool and going to give us a better surface finish. But again, there are some opportunities for us to try to take advantage of improving these tool paths. I'm going to pause that and kind of come back up here. And you'll be able to maybe see this a little bit better against these two colors. But again, slow this down. And what it's doing is it's kissing the material, coming back, letting the chip escape, and then kissing the material, coming back, and letting the chip escape. So again, very advanced and smart toolpath that the dynamic mill is generating for us. However, it does take a little bit of time to cut each one of these details. So I'll just have to, again, come back in and optimize that a little bit more. So I'm going to fast forward that, let it kind of all play out. And there's going to be one last detail for us to consider, and that's going to be this face here, which is going to be where the nameplate is going to be placed. So there's two ways that you can kind of approach this, and it's more or less like how your part is going to machine. So in one argument, you could say that instead of cutting this detail before that detail, I would maybe reverse them, where I would cut this face so that this is solid and I get the rigidity out of the part. Or if I'm trying to optimize the swivels, I might cut this face first. You might get some vibration if this is cut away, since this is now considered like a thin wall. But you'll probably have to machine it and just see how things go. So in the optimization video, I'll probably reverse these around a little bit. But for right now, I'm just going to let that sit, and then I'm going to come in and do that last face there. So I'm going to X out of verify, and then we'll go ahead and do this last face. So we'll jump over here to the planes, and we'll go ahead and activate the 5th cycle 800, which is going to be our last cycle here. And it's rotated like this. Again, I would probably do this out as like a swarf where I'm cutting with the side of the tool, but I would have to like reverse this cycle 800 and then put like a wireframe line and make like a contour pass. However, I want to utilize the same plane here so we don't have to create multiple planes to mill out the logo here, or the name that's going to go on the front side. So I'm just trying to keep it simple on this one. When we do get to that optimized video, I'll probably utilize that. So let's go over here to toolpaths, and then we'll just do like another face mill. So if you go to the toolpaths tab, click on the 2D gallery, we'll get the face mill, and just make sure that if you have text here, don't grab the whole face, because then it would try to isolate the text and face mill those out. However, if I just go ahead and click on my loop, we'll make sure that my arrow's going this way, hit the green check mark, tool, go ahead and use that 5/8 end mill once again, so 0.625 end mill, and then we'll give a note here for the 5th cycle 800, and we'll put face afterwards. And then we'll go ahead and grab our cut parameters. Probably won't be able to take advantage of the one pass just because of how thick this area is, so I'm going to utilize the zigzag. If we have any errors where it's either getting too close to the vise, or maybe the toolpath isn't generating, we might have to come back in here and change some of our step overs. But for now, I'm just going to leave that as is. Depth cuts, it's still remembering the last face mill I did, which was the 4th cycle 800, and it's still that max ref step of 0.15625. linking parameters, maybe I can change this top of stock, see where it's coming from, but I'll click on that top of stock and just double check and just grab that quarter. So yeah, that did update. So it's probably going to make 2 passes here for me. If I wanted to, I could probably go to the full depths because my depth pass here is 0.15625. I could probably come back in here and either turn that off or change this top of stock to 0.15625. I'm just going to turn off the depth cut there and just see what it does with 1 pass. Okay, and then we'll go ahead to the planes, make sure that we're reading the second op top as our WCS, and then our T and our C are going to be 5th and 5th. And hit the green check mark and see if that generates. So I'm getting some errors here. I might have to change the parameters there a little bit. So I'm going to keep the operation. I'm going to go ahead and come back in here. And I'm going to just double check, make sure that my arrows are going the right way. My roughing angle, let's go ahead and change that to 90, see what happens. So it's coming back and forth that way. So that's not what we want to do. So I'll make sure that that is back to 0. Let's change some of these values here. Let's go across overlap. Maybe I'll make that 15%. My next area would maybe change this detail or change that detail and see what happens here. Okay, so just making it a little bit bigger, let us get that toolpath in there. It's just widening the across overlap. So I just made a change here in the across overlap from 10, so that's what it was defaulting to 15 degrees, or sorry, 15%. And it seemed to apply that toolpath for me. So sometimes you're doing the right thing, and you just have to change some of those parameters just based on the area that you're cutting or the tool that you're using. So let's go ahead and see what this all looks like. This, again, I think it's going to be a little up close and personal with the vise, and that's why I would try to utilize the side of the tool rather than the face of the tool. However, I'm going to verify that and see what it looks like. So verify. I'm going to probably pause here and then go to the end so I don't have to watch all this play. And I'll just take my play button here and just drag it all the way down. And then I'm going to make this not as transparent with my workpiece. Kind of see it solid there. And then I'm going to go ahead and play out the rest of this and then turn it down in terms of speed. Okay, so it's making its last cut across. And then when it finally gets here, I'll back that. So I'll hit B, kind of place that back. And again, you can see how close this would be if I go to the right plane. It's not terrible, but it's just a little bit too close for comfort in my opinion. And I would try to get a little bit more space out of that. So I think that face mill is pretty good. It's not like it would crash or anything, but it's just, you might scare the operator if you give him that program. So that said, I think we did a pretty good job with this. We can maybe look at in another video talking about the text here, but that should be pretty self-explanatory. We just got to set up some new wireframes or pull from the SOLIDWORKS configuration and whatever name or branding that we want to put on. So as far as talking about the toolpaths and maybe like optimizing, we'll do another video, but if we just wanted to get the first sample out, this is a pretty good program. I feel pretty good about it. And I'm going to leave it there, and I'll go ahead and catch you in the next one. Thanks. Bye.